This is still 8-4. What I think we're going to do with graphing of these is we'll probably take, since we have shorter periods today by about 7 or 8 minutes, we might be, excuse me, we'll probably go through the graphs kind of quickly. I mean, they're not really all that terribly scary to do, but that'll allow us to do a little bit of expanding and condensing as well. That's also pretty simple. So we'll probably finish out 8-4 and might start a little bit of 8-5 today. That'll get us finishing 8-5 tomorrow. We might even get to 8-6. 8-6 is the equations. 9 times out of 10, when you guys work with the equations of logarithms, natural logs, exponent, things like that, you fly through it because it is really pretty easy. That'll get us to, we maybe be able to quiz or be able to test by the end of this week. Let's play it by ear. If it's not the end of this week, it'll be it should probably be Tuesday of next week. So we're right at the very end of this stuff. Logarithms, exponents and logarithm chapter usually goes pretty quick. Then we get to start trading. We love trade. So graphing. When you're graphing logarithms, we're going to have the basic equation, y equals log base b of x minus h plus k. Where your h and k are your horizontal and your vertical shifts. So we're going to have a parent function and a shifted function. Your parent graph is going to be y equals log base b of x. This is going to be your parent function. And to those points that we picked for the parent function, we will shift our h and our k. Your h stands for what? Your horizontal, your k is your?
Vertical.
Vertical. Very good. Your domain is always going to be greater than h because x equals h is going to be a vertical asymptote. Right? Your value of h is going to be your vertical asymptote. If their base is greater than 1, it goes up and right. If the base is between 0 and 1, it moves down and right. That's really all there is to it with logarithm graphs. The other thing that's nice with logarithm graphs is that you only need 2 points, because if you don't have a calculator, there's only 2 points that you're going to be able to get. And that stems back, excuse me, stems back from the original properties of logs, where you had log base b of b is what? One, very good. Okay. And then the log base b of 1 is 0. So basically what's happening here is that you're going to be able to find your 2 ordered pairs. You're going to have ordered pairs that will wind up with a 1, and an ordered pair will wind up with a 0 for your y values. These are what you're going to choose out to make them work. Okay. This is how these things are going to work. It's really extraordinarily easy to work with graphing logarithms. So let's look at log 1/3. Oh, wait. High flying McGee here. I just started. I think I'm done with this. You don't play baseball, do you?
I do not.
All right, thank goodness.
Quit that in like 8th grade.
Oh, that's the loose one. Actually, it was a really cool picture.
Yeah, I didn't even, I don't know what these have these pictures.
I read the paper. They're
I
online.
never see it.
They're online. Here, try that one too.
Again?
Excuse me. Yeah. So let's go with this one. Wait, did you play too?
In scrub time.
Nice.
Didn't know you didn't play.
Yeah, we nailed the 3.
Oh, you did?
Yeah.
Nice.
No picture.
They were already laughing. Yeah, let's get out of here. So you're kicking them while they were down, huh?
Yeah, I guess. I have some good bench celebrations though, so we should get a picture of those. Do you? I do actually.
Copying that one with the college.
Monmouth?
Monmouth, yes. So here we go. When you're working with these, excuse me. Sorry. When we're working with this stuff, one of the dead giveaways for what knowing which one's going to be your H versus your K, your H's are always going to be grouped in parentheses. So this one doesn't have the H value. Does that make sense? Your H value would be thrown in parentheses, which means that your H here is 0, your K value is -1.
So would it be the same, like, if it was x minus 3, would your h be 3?
If it was in parentheses, yeah. If it was in parentheses, yes.
Okay, so it would be h equals 3?
Yeah.
Okay.
So for H, it's the opposite, for K, it's the same.
Correct. Just like it has been normally
Okay.
when we have those out like that, unless they were thrown in the parentheses. Okay? I think that was the only time we had to worry about that, and that was with comics. Excuse me. So, parent function. Your parent function in this case is just going to be y equals the log 1/3, base 1/3 of x. Now, since this base, excuse me, base is between 0 and 1, what direction does it have
Down.
to
To the right. I think.
go? Was it down and right? So we know it's going to do this. So I usually put that little hook in there to know what way we're going.
Okay.
We all right with that?
Uh-huh.
Now we look at our graph. We take our parent function. I'm going to pick values of x that work. Basically, I'm going to pick values that make these properties hold true. Okay. I'm going to pick what base am I going to pick to make this at 1, at 1/3. I know I'm going to have an ordered pair at 1/3 and 1. So I know I'll have one of them at 1/3, comma 1. I also know that if I pick 0, if I use log base of 1/3 of 0, I mean, did I write that backwards? It's log base, yeah, beta 0, yeah. Log base was 1, sorry. Sinuses. I found a package of, you know how cold medicine has expiration dates? Found one from 2007. Didn't take that.
I wouldn't have.
That would be bad.
Wait, so is the 1 going in for the x or
Yeah.
the log? Okay.
So that's how you're generated through. Yes, ma'am. For parent, yeah. It's nice. So we're moving, doing something like that. Now, for the shift then, what do I have to do all the points at? Yes,
Does
ma'am.
that one have to be, the line supposed to be dotted too?
Thank you.
Just drawing it out, say that.
It's just something to
That's what I do on average.
To that, each one of these points have to move where?
So left, or down.
Down 1. That's it. Okay. And that's what's nice about logarithms. Logarithms are really easy to graph. Yes, sir.
Okay. Why is it 1/3 1?
If you pick x to be 1/3, you get log base b of b.
Okay.
The property says that that equals 1.
Okay, so when there's x to be 1.
And that means 1/3 to the 0 power. It goes through that.
So do we not use the rest of the equation, you just use the parent function when you're doing it?
Yeah. You use the parent to get those, and then you just shift them. So these points just move down. All right. Oh, there. Let's try another one. Ugh. With the k value. Let's try another. Let's throw a k in this one too. Plus 4. Why?
K is,
Let's try another one. Excuse me. And obviously, the other thing that works with when you graph these, excuse me, when you graph these things through, if you are using your calculator, you'll notice that in your tables, you're only gonna get clean values usually twice. Okay? And then pull them through from that. It's always nice if you have your calculator to kind of verify what you just did to make sure it worked. A lot of these are gonna be pretty simple to graph. There's really there really isn't much craziness, to be honest with you. The book calls it plotting convenient points. We just like to use them, as your parent and work them through. So if I go log base 5 of x plus 2, all plus 4. I figured I should put an h and a k and call it a day. That means my parent function would be at y equals log base 5 of x. I have an h value of what? -2, and a k value of 4. Now, I forgot to draw my asymptote on the last one. Where was my asymptote on the first problem? Do you remember?
Zero.
At 0. It was h was equal to 0. So I have what direction is this graph going?
Up and to the right.
Up and to the right. So it's going to do this. Okay. So I have log base 5 of x. So we start this through.
How do we know it's gonna be up to the right?
There's only 2 ways it goes. It's if your base is greater than 1, up and right. If it's between 0 and 1, it's down and right. I thought there was one of them. Didn't it have like an equal on it on one of those?
No.
Now and they had two.
Oh yeah. I wonder what happened if it's at base 1.
You'll never know.
I never noticed it didn't say that. That's weird. All these years, never noticed that. Anyway,
It's like one of those to do it.
so let's see.
I'll figure it out.
So we have log base 5 of 5 is 1. That means I have an ordered pair at 5 and 1. Then log base 5 of 1 is 0. So then we're at sorry. Okay. Should drink the coffee. It's so much easier to try and be here when you don't feel well than it is to actually miss. So substituting values through, like the book will say, plotting convenient points. I'm sorry, guys. To each of these values, where are you going to shift them? Left and
Left
up. Okay. Now, one of the things you'll see when you plot them through, it will ask you about domain and range. Since you have a vertical asymptote, you are domain restricted. These graphs are always going to be to the right of your asymptote. Okay? That's why they said that your domain will always be x is greater than your h values. Whatever your h value is, that's going to be your domain. Your domain is going to be all x greater than -2. Your range, will there be restrictions on range? Your range will give you all real. Okay? Your range is going to give you all reals because there's no horizontal asymptote that stops you. There's no ceiling, there's no floor. That's different with exponential functions. You had ceilings and floors. Okay? These are just a little bit different. Excuse me. I'm going to let you guys finish the graph ones. I want to talk a little bit about expanding condensing. I honestly don't believe that graphing logarithms are really tough, really, to be honest with you. So, I do want to talk about 2 properties of expanding and condensing logarithms. These properties will allow you to solve equations rather quickly. So, Excuse me. Do you mind if I go another slide here, just to put them up real quick? So, a little bit of notes then from 8.5. When you have a logarithm, and let's just say it's a log base b of x times y. This is the exact same thing as saying this. Log base b of x plus the log base b of y. Okay. Excuse me. The reason why we write it out like that is because it goes both ways. You can expand or you can condense. When things are being added together with logarithms, if they have the same common base, you can put them together as multiplied. Okay, same idea. If they're being multiplied, you can split them apart and be added. Excuse me. Sorry. The other one that we look at is division. If multiplication goes with adding, what do you think division goes with? Exactly. When you look at it in terms of division, it's log base b of x divided by y. That's the same thing as saying the log base b of x minus the log base b of y. And then the last one is an exponent rule. Whenever you have the log base b, we'll just say x to the nth power. In order to break that apart, you take the exponent in front of the logarithm. So these three properties expand, going from left to right, and they condense, going from right to left. Like I said, one of the reasons why we do this stuff is so that you can solve equations tomorrow and whatnot. Let me show you an example of what this looks like as far as what you would have to do with something. There, got the right. What I want to do is expand this. Bless you. I'm going to expand this. I'm going to rewrite this in terms of multiple logarithms, because then you might see you can simplify and things like that. Excuse me. In this problem, you have log base 8 of 64 times x squared. I'm going to put that like that. Which means you can split it into an addition problem. You get log base 8 of 64 plus the log base 8 of x squared. You okay with that so far?
Mm-hmm.
How can you rewrite 64? 8 squared. So that's the same as log base 8 of 8 squared, which is the same thing as 2 log base 8 of x. I just brought the exponent in front. And what's log base 8 of 8 squared? 2. So your answer would be 2 plus 2 log base 8 of x. Now, if you had to solve for x, I just had to roll a toilet paper, but I stole. I think it's in my bag, if you wanna use some to help yourself. Now, what this will allow you to be able to do is that if we set that equal to any number, then you can work backwards to solve for x by using these expanding condensing style problems. Okay. Let's try another one. Let's try to clean up this next. This is log. Yeah. Try and condense that, or excuse me, expand that. So again, what we can do is start splitting it apart. You'll probably pick up pretty quick that you can shortcut some of the stuff without so much of a hassle. I'm gonna get log base 3 of 12 to the 5/6 log base 3 x to the 9th. Really, the only thing you can do now is just move the exponents out in front. Because I can't rewrite 12 as a base 3, can I? That I'm aware of. And you'd like to think you can, I don't think we can do anything with that 9, even though it's the exponent up top there, because it's the base, the value of x. Excuse me. Now, there are other, back in the old days, you had to solve this problem by using tables and long division. You guys have a calculator. Okay. And like I said, the idea of being able to split these things apart is going to be able to solve for x when we set it equal to something else. Okay. Let me show you a condense. Go the other way. We'll go the other way. Now, one of the things you'll see, one of the things you'll notice when you have all these additions and subtractions and stuff, you start thinking about it in terms of do they have the same common base first? And then you have all this addition between each one of them. That means everything's going to be multiplied together. When you see numbers in front of the logarithm, what does that mean happens to each one of those values after the log? It's the exponent. Very good. So I know that since these guys all have the same base, I'm going to have a log base 4. 2 to the 7th, x to the 5th, y to the 3rd. Bless you. I hope you don't get the plate. Yes, ma'am. If they're not all the same base? Well, you might have one where it's like log base 5 and the other one are 4s. So it would just be, we can't multiply them together. It just,
But then like the one
yeah. Now this one, 2 to the 7th, well, you could probably simplify that because of the base 4, right? 2 to the 7th, well, let's see. 2 to the 5th is 32, 64, 128. So that'd be 128. Now, 128, let's see, that's 4 squared is 16, so the 3rd is 64, right? Maybe. It is. But then 128 would not be 4 to the 4th, because 4 to the 4th is 2 squared. What's wrong? I'm just saying, sometimes you might, sometimes you can't. I was just saying to get there. Now, you don't have to write it as 128, you can just leave this to the 7th. Okay? I'm not gonna lie, some of those can get tricky. I may or may not get tricky today. I might pull off out of it. I might as well. Want some problems?
Yeah.
I didn't have that much today with these things, so this by taking, because we got short on Friday because of the assembly, knowing today we had another assembly, I could probably put these two together and call it a day. Graph wise, I think we probably just do 4, call it a day with that, and then I'll give you some condensed ones, see how you do. What?
You guys all
You know, he wasn't the one that gave it to Dad.
I know, but he's the one that promotes it. He's the one that hypes it. Oh, he's the hype. I like the dad. I like the dad. I was like,
What page is it?
Oh, sorry.
Huh? Actually, tried to correct it.
I wanted them because they like selected. They select food. So, oh yeah, that was funny with Matthew.
Try those out. Okay. The properties, when they throw them in there with natural logs, remember natural logs just log base E, right? The rules still hold true. All the rules hold true for natural logs as well. These are just log base E, okay? So I gave you some condensing, some expanding, and 3 graphs. Preguntas para su tarea.
No.
Okay. Okay. They have the wrong.
Yeah, that's
10:01.
why you're so early, 'cause she would've sounded like.
They sent out an email on Friday about their revised schedule for today. It's that. I didn't disseminate, remind anybody this morning. So that got sent out this Friday, I think. But yeah, that's the correct one. They found out they wanted to have more time for the assembly, I guess.